Hello and welcome everyone. So I'll be explaining you Div3 693 CF round problem B fair division. Uh, well, the problem is fair division. But for me it was a bit of unfair because I missed a very crucial test case inside the contest. I will show you what it was, and actually eventually I solved it. Let's see. So the statement actually said that Alice and Bob received n candies from their parents. So basically we have to do is, okay, we have an array of n integers, n is up to 100, and the values or the weights or the values of this array will be either 1 or 2. Now we have to divide this array into two equal sums. Can we divide this array? But here's a condition. We cannot just divide 2 by 2. Okay, well, we just have to use the values of the array, okay, separately, these values, only these values, no manipulation of the values, which means you cannot make this 2 to 2 ones. Okay, only this value, you have to manipulate only the values that you are given, and you have to find out two equal values. If you can make two equal values, okay, by using all of the candies, and you have to the number of candies that Alice and Bob received, and the next line is that we have to if all the candies can be divided into two sets with the same weight. So we just need to do that. Somehow we have to make two equal weights using all the candies, which means all the values of the array. Now the values are what? The values can be either 1 or 2, right? Either 1 or 2. Now, as you can see, I'll describe it with an explanation. First of all, we need to understand what are they saying. Okay, now first of all, first observation that you need to understand is that they have said two equal weights we have to make. Okay, so we know if two values are equal, let's say this is weight 1 and this is weight 2, we need to make this equal, right? When does two values become equal? When either both of them are even, let's say this is an even number and this is an even number, 6 plus 2 is what, 8, or both of them are even, or like 7, or both of them are odd. So if two of the values are even or odd, then this, look, if two of the values are even, which means, what I'm trying to say is, if the sum of all the values, let's say if the sum of all the values, okay, so now you have to understand here one thing. First we'll sum all the values, okay, that we're given, and we will check whether it is even or odd. Okay, now if it is even, if it is odd number, then you will never divide it, because odd number comes, any odd number, you cannot divide it into two equal weights, right? One has to be greater than the other. Okay, and to prove that, we can also say that two values can be equal if both of them are even or both of them are odd, right? If both of them are even or both of them are odd, then they can be divided into two similar weights. Now when you sum that, when you sum those two even or two odd values, what do you get? You get an even value always, right? So it is clear that if the sum of all the values, I mean all the ones and all the twos, if the value is even, if the value is odd, then you can never divide it into two similar weights of two kinds, right? You cannot make that. But if the value is even, there's a possibility. I'm not saying it is 100% sure that we will get. There is a possibility that we can get. Now, so for the 100% part was that if the sum of all the values is odd, then it's no, definitely no. If it is even, then we have to check some conditions here. Now, what are those conditions? I'll tell you where did I make the mistake. First I actually wondered, okay, if sum of all the values are even, then I will just simply count all the ones. Look, this is where I made the mistake. I'm telling you, I'll count the ones and I'll count the twos, right? And I will check whether the count of ones is even and the count of twos is even. Then the answer is yes, otherwise the answer is no. Okay, so I was just thinking about these sort of test cases, 1 1, and if it's a 2 2 2 2, I will always get something, like, because they are all even, I will always find something which I can divide it into two terms of same weights. And I also thought this type of cases, and also this type of cases, like 222 and then 1 1, then it's not gonna happen. Okay, I actually thought then, okay, if any of their count is odd, then it's never gonna happen. Otherwise, if both of the twos count and ones count is even, then it is always possible to divide them into two parts of same weight. Turns out what? That's not possible. There's a tiny bit of tricky test case here. I'll show you what is that case. The case is this. Look, what if we're given this 2, 1, and 1? Okay, now how many 2's are there? 1 2's. How many 1's are there? 2 1's, right? Now this does not meet my expectations earlier. Okay, so what I actually I run out that, okay, if any of them is even, then the answer is always no. Turns out what? This is yes. This is yes, because I can make this 1 1 2, so this is one part and this is another part, right? So I have to, so it is always possible that count of 1 and count of zeros are even. Then the answer is yes. Yes, it is possible. But what is not possible is if either of them somehow is odd, then it's not possible. That's wrong, because they can be possible, because this is the tricky test case here. 2 and 1 and 1, right? This is the tricky test case. And also you have to take care about whether 1 is equal to 0 or not, right? This will also be one case that you need to take care of it. Let's say we're given only 3 2's. So what are we left? We don't have any 1. Actually, yeah, that's that. Okay, so we don't have any 1. We could say that, yeah, we don't. We are having only odd terms of 2's, so it's not gonna happen. So what actually we did is, let me take you to the code part. I'll show you the code part here. You will understand more when I do. Okay, so moral of the story, the tricky test case was this, right? There are some test cases like that, similar to this, but I found this one to be the tricky one. Now let's take you to the code part. Where is it? Okay, yes. So we took n, we took t, we took n, and the values, if they're odd, they're even. I'm counting the even values and also the odd values, and I'm summing the values. If if the sum value is odd, I told you it's not possible. I showed you with example. And if it's even, then there are some possibilities. First I checked that whether both of them. First I checked whether P and Q, both of them are uh, zero, which is actually meaning that whether C and T 0, which means count of 0 and count of 1, are even. If they are both even, then it's possible, yes, somehow I can get two equal weights. If it's not possible, then earlier when I got wrong answer, I did directly no, but there are some conditions that I might check. I need to check, which is what? This. We need to check whether the count of 0 is odd and the count of 1 is 0 or not. If it's possible, then I'll have to print no, which is actually I'm referring to this test case here. This one. If odd times 2 and oh, I'm sorry to say one thing. Sorry. Actually, here's 0 meaning by counting of 2 and 1 meaning by counting of 1. Okay, so we were just referring, this line is simply referring this test case 2 2 2. If there are odd number of 2's and even number of 1's, zero number of 1's, then the answer is always no. Otherwise, what is the main part here? The necessary condition is that we have to check whether count of 1, not the both count, just the 1 count. Why is that? Just to take care of this sort of test cases. Because if you analyze it, 2 is even, right? And 1 is odd itself. So if you count the number of 1's, it is actually that we need it actually. That's all we need. We just need to this is the here what we did actually, we just found out the count of 1. If the count of 1 is odd, if somehow it is odd, then there's no answer at all, which is actually tackling this test case 211. Okay, 211. Because look, what we did earlier, what if actually one of them is odd, if actually at least one of them is odd, and I'm giving it no, it's not possible. But turns out what? Only one's count is not two's count. Only one's count is more important here. Okay, so two's count is not important. One's count is important. If one's count is odd, because 1 itself is odd, that's why it's important. So if one's count is odd, I'm just returning no. Otherwise, it's gonna be yes. Because if 1 is even, let's say 1 is even times, we have 1 even times, then I'll show you. Let's say I have 1 even times, 1 2 3, okay, but I also have what? I also have let's say that I have 1 even times and 2 odd times. Let's show you that it's possible always. So what we did here, we have what? 5 2's and 3 1's. Let's say if we, this is always this is actually oh sorry, I'm sorry, not sorry, even times, let's say we have what? Even times 1 and odd times what? 2. How is that gonna help us? We can always find some weight here. Let me show you how we can make. Okay, we can make something like this, right? 2 2 and this 2, this part and this part, right? So this is the definition of the line that I coded here. It does not depend. Turns out what? The final conclusion is it does not depend on the count of 2. It depends on the count of 1. If count of 1 is odd, You can never do that. You can never divide that. That's exactly what we did. If the count of 1 is even, it does not matter what the count of 2 is. We will always get our answer yes. Just like that here. Okay? And I also showed you how can we make if the count of 1 is odd and the count of even is count of 2 is even and the count of 1 is odd. Sorry, count of 1 is even and the count of 2 is odd. Let me show you another one. Count of 1 odd and count of 2 even. Let's see. Even. Okay. Look, you can never make it because the count of 1 is odd. You may try one. Let's say we take this, and take this. 2, 2, 4, 5. 1, 2, 3, 4. 1 is always gonna be left because 1 itself is odd. That's what's the tricky part is. I hope I made you understand. I think I did the it took a very long time here. Sorry for that. I hope I made you understand with all the test cases that I just showed you. And yes, till next time, goodbye.